Hello everyone and welcome to my task for chapters 3 and 4 for Math 10A. My name is Alexis and I'll be taking you through how to find the greatest common divisor for three numbers and three different ways of how to subtract a certain problem. So first, we're going to find the greatest common divisor of three numbers, and they are 16, 24, 36. Basically, the greatest common divisor is the largest integer that's not 0 that divides into the number you are comparing without a remainder. The first method of finding the greatest common divisor. So the first method is we take our three numbers and then we figure out what times what equals that number. For example, 16. 1 times 16 equals 16. What's another way to do 16? 2 times 8. 2 times 8 equals 16. And the last way, 4 times 4 equals 16. So we write down all those numbers, and we do that for every single one. So 24, 1 times 24 equals 24. 2 times 12 equals 24. And we write down until we finish. So then, after we have written down all the multiples of that number, we go through and we see what they have in common. So all three have to have them in common, because as you'll notice, like 16 and 24, for example, they both have 8 in common, but 36 does not have 8 in common with them, so we won't be looking at 8. So the first number we see that they all have in common is 2. So we could think that that is the greatest common divisor, but actually, when you look farther down, you'll notice that every single one of them has 4 in common. And after that, there are no other multiples that they have in common. So from that, we deduce that 4 is the greatest common divisor because it is the largest divisor that they all have in common. Our next method is the tree method. So, let's back up. For 16, what we do is we take 16 and break it down. So what times what is 16? Well, we know 4 times 4 is 16. So we branch off the 16 and we write 4 and 4 to show that that equals 16. But from there, we can break down 4 farther. So we take the 4 and we say what times what equals 4? 2 times 2. And so we make our branches yet again, and we put 2 and 2 to represent 2 and 2. We do that for the 24 as well. What times what is 24? Well, we know the 6 times 4 is 24. So we branch off the 24, and we can put the 6 and the 4 right there. But 6 and 4 also can be broken farther down. So what times what is 6? 2 times 3. So we branch down and do 2 times 3. What times what is 4? 2 times 2. So we branch down and put a 2 and a 2. And what you have to realize is that all these numbers below it are divisors of the number at the top. So the last number, 36, 9 times 4 is 36. We branch down, we put the 9 and the 4. And then we realize we can go farther because 9 and 4 can be divisible by other numbers. So 9, 3 times 3. So we put the branches, we put 3 and 3, and 4 is 2 times 2 yet again. So we put the branches. And once we have all of this written out, we can see that all of them have a number in common, which is 4. They also all have 2 in common, but as I was saying before, we're trying to find the largest number they have in common. So we would circle the 4. The last way, I might butcher the name of, but it's the Euclidean algorithm. And basically, what happens is we take the larger and the smaller number and we put it into the algorithm. The algorithm is that this larger number will always be what you're trying to get the formula to equal to. And the smaller number is the number we use to times by another number to get closest to the bigger number. For example, 36 is our larger number. So that's what we're trying to equal to. And 16 is our smaller number. So we have to figure out what times 16 gets us closest to 36. So 16 times 2 is 34. And if we went 16 times 3, we would get too large of a number. So since 16 times 2 is 32, we have to figure out how much we have left over. Like, what do we have to add to the 32 to get to 36? So 32 plus 4 equals 36. So we do 16 times 2, which is 32, plus 4 is 36. But we don't have a remainder of 0 yet because we have this plus 4. So we have to take this 16 and this 4 that we added, and we have to do it all over again. So we're trying to get to 16 since it's the biggest number. And then we take the 4 and we have to think, what can we times 4 by to get to 16? Well, we know 4 times 4 is 16. And so it would be 4 times 4 is 16. And then we would add 0, which means we do have that remainder of 0. And we can finish the problem there. This 4 right here is our common divisor, the greatest common divisor for the three numbers, because that is the final number we got to with a remainder of 0. Moving on to subtraction, we'll be using this problem, 34 minus 18, and I'll be showing you 3 ways of how to solve this. The first way is borrowing. Here's our formula. What am I trying to say? Equation. Here's our equation. So what we will be doing is just subtracting from each column. So we go down and we're like, well, 4 minus 8. Well, you can't minus 8 from 4. So how can we do that? Well, the borrowing method allows us to borrow from the tens. Since this 3 is 30, we can borrow a 10 from the 30. So we cross out the 4, and it becomes 14. But wait, we took a 10 from this 3, well, or 30. So we have to take away one of the 10s because we added that to the 4. And then we can do 14 minus 8, which equals 6, and 2 minus 1, which equals 1. So our answer would be 16. The second way is making change. We got the same problem set up the same way, but the way that we solve it is quite different. What we do is we take our 18 and we think, what can we add to the 18 to get to the 34? To make it simple, you can break it down as far as you really want to. So 18 plus 2 is 20, and I thought that was a good place to start because we're getting it to a number that is easily added to. So we take our 20 and we say, okay, what plus 20 will give us something close to 34? Well, 20 plus 10 equals 30. So we're getting closer to 34, but we're not there yet. So our final part would be 30 plus what equals 34. 30 plus 4 equals 34. And we finally got the answer we were needing for this problem. So now you might be asking, okay, so we got the answer, so how are we going to figure out what the actual answer to the problem is? Well, what we do is we x-nay this, and pretty much x-nay this area. I didn't put an x over it, but because this is how, these numbers are how we were getting to the 34. As in, those are the numbers that we had to add something to get to the 34. They're not part of the actual, like, what we need. So, right here, which I circled, are the numbers that we were adding to get to the 34. We add up those numbers, 2 plus 10 plus 4, and we get 16. 16 is the answer to this problem because that is what we had to add to the 18 to get to 34. Now our final way is breaking up and bridging. So what we do is we break up the 18 into smaller chunks. What plus what plus what plus what plus what equals 18. You can do as many numbers, as little numbers as you want, but just break it down to make it easy enough for you to subtract. So 10 plus 4 plus 4 equals 18. So as you can see by this arrow, 10, 4, and 4 I have put here. But what we do is we take this 34 and we do 34 minus 10 equals what? 24. Why we do the 34 minus 10 is we were breaking down the 18 into smaller chunks to subtract from the 34. So 34 minus this 10, that means we already subtracted the 10, equals 24. So we take that 24 and we do the next number. So we do 24 minus 4, because we have this 4 right here, equals 20. Our last step will be take that 20 and minus the last 4. So 20 minus 4 is 16. That means that 16 is our answer. And if you were to add up this row, you could see that that's 18. So we overall had subtracted 18 from the 34. Thank you so much for watching. I hope that this was very insightful and helpful for you.